Our company, DSK2 Biometrics, specializes in security plans centered around biometrics. Our mission is to bring security and comfort to all people. We will use top-notch biometric technology to suit all our clients.
Here's our outline, which includes 5 main ideas. These are the company, the science behind the biometric scans, the human body systems involved, the accuracy of our biometric methods, and DSK2 in action, which includes a success story, how we beat the system, and some privacy issues. In order for you to understand why we chose the specific biometric methods that we chose, let's go through the science behind them. For the toe prints, we have touch capacitive surfaces that capture the patterns of ridges and valleys of a toe. Then, a light-sensitive microchip produces a digital image, and the computer analyzes it automatically. It uses a sophisticated pattern matching software to turn it into a code. This code also checks for matching minutiae, as each human has around 30 minutiae, and no two humans should have more than 8 in common. Next is our facial recognition. We have systems that use computer algorithms to pick out specific and distinctive details about a person's face. These details include, but not limited to, the distance between your eyes or the shape of the chin. These are converted into a mathematical representation, which are then compared to data on other faces looking for a match. Finally is our retina scan. We have a system that casts an unperceived beam of low-energy infrared light into an individual's eye as they place it close to the scanner. This beam of light travels in a straight path and hits your retina gently. This beam of light traces a standardized path on the retina, and the system then checks if that pattern is equivalent to the safe pattern it has in its system.
In order to understand the biometric applications, it is important to discuss the human body systems involved. Firstly, for toe prints, the integumentary and nervous systems are involved with this biometric application. Specifically, the skin on the pads of the toe and finger is unique to each person and is not genetically inherited. The purpose of toe prints is to help to protect the skin and prevent blisters because the ridge patterns prevent fluid from forming, reducing the chance of getting a blister. The patterned skin also allows for better grip and allows for sensitivity to touch and heat. This is because the nerve ends at the surface of toes send signals to the brain, working with the nervous system. In addition, the facial scan is involved with the muscular, skeletal, and integumentary systems. The structure of the skeletal system forms the basis for the shape of a person's face. For example, the jawbone can be a factor that the facial scan uses to differentiate between two people. In addition, the muscles in the muscular system differ in depth and how they layer on top of the face, which changes how a person looks. Skin color or blemishes on the integumentary system can allow for a unique face for each person as well. For example, a person may have a large mole or have more muscle tissue on the frontalis, differentiating from a person who has clear pale skin and a small forehead. Third, the retina scan is involved with the nervous and circulatory system. The blood vessels, eyes, and brains are the organs that are involved. People can be identified based on the unique pattern of blood vessels in the retina. Blood vessels are part of the circulatory system, and the pattern is not formed by genetic factors. Therefore, like fingerprints, they are unique to each person. The blood vessels' purpose is to deliver oxygen and nutrients that are needed in high quantities to allow the eyes to function. The retina is also part of the central nervous system, and it allows it to send visual information to the brain. The way that the retina observes light to send to the brain can also be a factor in identification.
Accuracy and potential limitations. Starting off with a toe print, the accuracy of a toe print is similar to a fingerprint, around 98.5% accurate. Therefore, toe prints prove to be just as unique as a fingerprint, and each person's print matches their own unique identity. Limitations, however, may be the additional step of having to take your socks and shoes off for the toe print to be scanned in the airport, whereas a normal fingerprint does not apply to that. Next, we have the facial scan. A facial scan has an accuracy of around 99.97%, making it the second most accurate scan of the 3 we have provided to use in the airport. A facial scan utilizes the natural features of a person's face to identify their identity. However, there are limitations such as cutting and dyeing hair, low quality images that are used to identify that person, the addition of facial hair, and more which apply, making the accuracy lower for this method. Lastly, we have the retina scan. The retina scan is one of the most accurate biometric processes with a 99.99% accuracy and around 20,000 times more accurate than fingerprint type methods. This is due to the use of light to analyze each individual's unique retina in the orbital region of the body. This makes it more accurate than a fingerprint scan because retina scans review blood vessel patterns as well, using vein geometry located in the retina, which are harder to mimic than a fingerprint. Limitations of a retina scan, however, are mainly from people's opinion of use. Because of the scan being somewhat unpleasant from putting your eye in a space to get a bright light beam projected onto it. This makes some believe that there's a risk in health or injury to your eye by using this process. Success story. As the safety of Con Airlines needed more security systems, the DSK2 Biometrics team submitted their ideas to improve the overall security of the airlines. DSK2 Biometrics was accepted to utilize their biometric process of facial recognition, retina scan, and a toe print in the Con Airlines for the safety of their passengers. However, the boom in DSK2 Biometrics did not occur until the occurrence of Genevieve, a notorious murderer that had not been located since the murder of her family in Arlington, Texas, 1999. Genevieve had been looking to take a flight out of the United States to Switzerland, but had been caught in the DSK2 Biometric security systems in the process of gaining her facial recognition, retina scan, and toe print, which showed the past files of her and her wrongdoings. Through this, their methods at Con Islands had been improving the process and accuracy of security, with every passenger getting scanned 3 times in one go, to provide one of the safest possible airport security systems available in our generation, making DSK2 one of the most successful biometric companies.
Issues of privacy are a big concern when considering biometrics. Firstly, central data systems are a privacy concern because all users will have their data stored in one system. If the data is compromised, it will be a huge problem. To prevent this, data will be protected with the utmost security, and we will make this one of our priorities. Another concern is third-party use and replication. If data is given to a third party, it can be used for purposes outside of what a patient has given consent. It can also be replicated. This will then lead to a person's data being used outside their control. Eventually, data may even be used to survey citizens without permission. This is completely unacceptable. So in order to prevent this, we will establish regulations to protect privacy rights, such as the right to be forgotten, clear consent, and penalties for failing to follow rules, modeling the EU standards. Data will not be handed to any third parties and will not be used for any other purpose except for identifying travelers at the airport, unless consent is given. To solidify this, a document will be written to hold DSK2 Biometrics accountable for any breaches in this contract. Lastly, another concern is that if identity theft does occur, data cannot be revoked or reissued. This is a very unlikely thing to happen considering the multimodal biometrics used in this security system. However, if this somehow does occur, we will remove the victim's data from the database and provide them with an alternate security measure, such as issuing a card.
In our case, it would be very difficult to beat the system since our system is very secure. Due to our multimodal biometrics, one of the biometric scans, the retina scan, has a 99.99% of accuracy rate. And the other scans can serve as backups too if the retina scans somehow fail. Therefore, it would almost be impossible for a mistake to occur. In addition, the person would be confined in a circular machine while being scanned with security watching them from the outside. They will not be able to escape the machine without being caught. In addition, it would be nearly impossible for a person to steal someone else's face, toe print, and retina scans, making it basically impossible to commit identity theft with all the security around.
Our product, as seen here, is efficient and effective. It will be a 2-in-1 product. Not only will it identify if the person has possession of metals, it will identify the person. The person must take off their shoes and face towards a camera that will quickly run a facial and retina scan. If the data does not match the person's identity, then the foot clamp will constrain the person until further instruction. However, the millimeter wave scanner coupled with DSK2 Biometrics additional features is costly, around $200,000. Therefore, we will also offer a simplified version of our security plan that simply scans for biometrics, though it will look similar to the millimeter wave scanner. DSK2 also offers a free 1-month trial and promises highly trained staff to assist with the initial process. Our staff will monitor the machine. These are some of our references. This is also our references, and these are the images that we use.